Here we go, section 7, multiplying and dividing expressions. Before we start, we need to review something. Hopefully it's a review. Hopefully you kind of know how to do it already, but if not, I'll teach it like you've never seen it before. Before we begin, we need to review the concept of repeated multiplication. If the same number is multiplied by itself multiple times, we can write the repeated multiplication with exponents. What I mean by that, 3 times 3 times 3 times 3 is the same thing as 3 to the 4th power. No. We're working with them in the problems. That's the reason I'm having to review them. In the example 3 to the 4th, the number 3 is known as the base, and the number 4 is the power of the exponent. Down through this chart, let's just go over them real quick. 3 to the first power is the same thing as just plain old 3. It means you have 1 3. 3 to the first power means 3. 3 to the second power means you have 2 3's being multiplied by each other. 3 to the third power means you have 3 3's being multiplied. 3 to the fourth means you have 4 3's. 3 to the fifth means you have 5 3's being multiplied by each other. Should make sense. Y to the fourth is the same thing. Means you have 4 y's being multiplied by each other. 5 times y to the fourth. This is where I really need you to pay attention. 5 times y to the fourth means you have a 5 and you have 4 y's. Makes sense. 5 times y times y times y times y. I need you to internalize that and make sure that you know what that means. If I ask you to write 6 times x to the third, that's 6 times x times x times x. If I ask you to write, let's do something like this. If I ask you to write 10 x squared y to the third, if I ask you to write that out, that's the same thing as 10 times what? Times. Okay. And what the reason I want you to be able to do that, watch what I'm about to do. If I wanted to multiply x squared times x, write that out. What's x squared mean? X times x times, and then we want to multiply that by x. So do you see you have 3 x's now? If I wanted to multiply 5x squared times 4x squared, y'all watch what we're doing, because again, this is going to be important to our lesson. If I wanted to multiply 5x squared times 4x squared, write that out. That's 5 times x times 4 times x times x. Let's talk about how we could rewrite that. And when we work through these problems, this is what I want you thinking. Is about, okay, if I wrote it out, what would it look like? Can I multiply in any order? Like if I wanted to, could I multiply 5 times 4 first and then multiply? Sure. What property says I can do that? Commutative. I can move this number up here if I wanted to and go ahead and multiply by it. That's the commutative property. So I could rewrite this as 5 times 4 times x times x times x times x. So what is that? 20 times x to the... So 5 times x squared times 4 times x squared is 20 times x to the fourth. I'm going to do a couple more, because this is not the lesson. This is stuff you're going to have to use to do the lesson. If I want to do 6x to the third times 2x squared. 6x to the third, just tell me what it means. Tell me what it means. 6 times 3. 6 times x times x times x. 2x squared means 2 times x times x. Makes sense. 6 times x times x times x times 2 times x times x. That's what that means. I can multiply them any way I want to, so I can do 6 times 2 first, which is, and then x to the third and x squared is a total of x to the fifth. Makes sense. Let's do some without rewriting. 2x to the third times 4x squared. I can multiply 2 times 4 first if I'd like, and that is x to the third times x squared. That means you have 3 x's times 2 more x's is a total of x to the fifth. Now let me hopefully not confuse you, but here's where people get this mixed up. X squared plus x. You can't add those together. Can you explain to me why I can't add those together? They're not like terms. But I could add 2x plus 3x. Those are like terms. I can't add 2x plus 3x squared. Those are not like terms. Okay? the variables, before you can add them, have to be identical. But even though I can't add them, I can multiply them. Like 2x and 3x, if I said 2x times 3x, 2x times 3x, anybody tell me what that is? 6, and x times x would give you x squared. Good job, Tom. Even though I can't add 2x times 3x squared, even though I can't add 2x and 3x squared, I can multiply 2x times 3x squared. 2 times 3 is 6. You got 1x there and 2x is there. That's x to the third. Makes sense. A lot of people, and if you can understand that, that'll help you out a lot down the road. Can't add unlike terms, but you can multiply unlike terms. Okay. So let's start the lesson. Just keep that in mind as we go through this. Remember that distributive property we talked about the other day. Example 1, that's all you're doing. Simplify by removing the parentheses. All that means is do the distributive property. Had a student tell me, let's see, what was it, my 4th block group the other day, that when she was at her prior school, that they called it watering the flowers. And that might not make sense. It's like, what in the world does that mean? Let me explain what she meant by watering the flowers. Look at this problem. 2 times 4x plus 5. What is 2 being multiplied by? 4x and 5. She said the 2 is kind of like a watering pot. Okay? The 4x and 5 are kind of like flowers. Okay? By the way, from yesterday's lesson, 4x and 5, what are those called? There's 2 of them. Starts with a T. Those are terms. Thank you, whoever said that. Those are terms. You have 2 terms inside parentheses, and I'm going to start using that word more instead of things. I think is what I've been calling them. I have 2 terms inside parentheses. The 4x is a term. The 5 is a term. Those terms are like flowers. Okay? If we're going to multiply by 2, that's kind of like watering the flowers. You don't want to water one and not water the other. And a lot of people do that. A lot of people say, well, that's 8x plus 5. It's not. Because if I say this is equal to 8x plus 5, did I multiply 2 by both of them? I multiplied 2 by 4x. All you're doing is you're picking this 2 up and you're multiplying it by this and you're multiplying it by this. That is all the distributive property is. So 4x becomes 8x. Positive 5 becomes positive 10. That is all the distributive property is. 2 times 4x plus 5, multiply the 2 by this, multiply the 2 by this, there's your answer. Makes sense. Each term gets watered. Each flower gets watered by the 2. Next problem. That does make sense. Thank you. Negative 3 times negative 4x minus 8, I believe that's right. You're distributing what number? You're distributing the negative 3. What are your 2 flowers? Negative 4x, negative 8. If you want to multiply negative 3 times both of them, well, first off, negative 3 times negative 4x. What is that? That is a positive 12x. Let me show you why. Negative 3 times negative 4 times x. Okay, that's what you're doing there. Negative 4 and x are being multiplied. You want to multiply by negative 3. You can just multiply those 2 together if you like. That's 12. And then you've still got that x left over. 12x. Now the next thing you have to multiply is a negative 3 times a what? A negative 8, which is a positive, plus 24. Think of that 8 as being a negative. You see how it changed to a positive? The reason it changed to a positive is because you have a negative 3 times a negative 8. A negative times a negative is a positive. So your answer there is 12x plus 24. Are there any questions on how I got that? I sure will. That same problem? I sure will. Negative 3 times negative 4x minus 8. We're wanting to distribute the negative 3. You have 2 different things that you've got to distribute it to. You got to do negative 3 times negative 4x and negative 3 times negative 8. Negative times a negative, that's going to give you a positive. So that's pretty much the same thing as multiplying positive 3 times positive 4x. 3 times 4x. If you have 4 x's, multiply it by 3, you now have 4, 4, and 4. You now have 12 x's. right? You also have a negative 3 times a negative 8. A negative times a negative there is also a positive, and that tells you whether to put a plus or a minus in between it. If that had been a positive 8, you'd have a negative 3 times positive 8, then you'd put a minus there. So negative 3 times a negative 8 would be a positive 24. Makes sense? Good deal. Next problem. Getting a little bit harder. 3x times 7x plus 2. You have a single term on the outside, 3x. You have how many terms on the inside? You have 2 flowers. Good. 2 terms on the inside. Each of those flowers, each of those terms are going to be multiplied by what? By the 3x. So we got to do 3x times this and 3x times this. That's the reason I showed you that stuff before we started. 3x times 7x is not, you got to be careful, it's not 21x. 21x squared. Because what we're going to do there, we're going to do 3 times 7, which does give us 21. But then we got to do x times x as well, which is x squared. So that's where, that's the problem we'll have to fix today. Because most people have trouble with those. Most. They say, well, when you add them, you just get plain old x. And you do. If I added 3x and 7x, what do you get? 10x. When you multiply them, different story. You got to do 3 times 7 and x times x. Because what does 3x mean? 3 times x. What does 7x mean? 7 times x. So how many different things are being multiplied together there? 4 things. Multiply these two together, multiply these two together, and you do get 21x squared. The next thing we're going to do is 3x times the plus 2. Is it a plus or a minus? Plus 6x. And that's the same reason. 3x times 2 is 3 times x times 2. How many different things you got multiplied there? 3, and I can only do the 3 times 2. That's 6, and you still have the x, 6x. Makes sense. Today, yeah, it doesn't get much harder. Well, actually, it doesn't get any harder than that. We're going to combine it with yesterday's lesson, then we're going to divide, and then we're done. 6x times negative 2x plus 4. How many terms are in parentheses? 2. What are you going to multiply each of them by? 6x. 6x, and we'll try to do it without writing it out this time. 6x times negative 2x is a negative 12x squared. Because 6 times negative 2, negative 12. X times x, x squared. 6x times positive 4 is positive 24x. Cubed. Yeah, don't say cubed. That's what power is cubed? Third power, good. Okay, now let's put this together with yesterday's lesson. Building blocks. All the math is building blocks. Okay, so we start out with a foundation, like you're building with Legos. If you build a house without a foundation, it's going to fall. So if you don't have a good foundation, if you didn't really understand the first chapter and most of this chapter, you're going to have trouble. 2b minus 5c. That's the reason it's always good to stay awake during class. Right? Okay. 3b plus c. 2b minus 5c minus 4 times 3b plus c. Today's lesson plus yesterday's lesson. The first set of parentheses, are there anything in front of it? Do we need those parentheses? No. 2b minus 5c. Watch closely this next step. Yesterday we just had a minus in front of it. Today we have a minus 4. Okay? Ignore this part, because we've done something with this. Do you see that this problem is what we were just doing? Negative 4 times 3b, negative 12b, negative 4 times a positive c is a positive or negative? A negative 4c. Now it's just like yesterday's lesson. Makes sense. Combine like terms. Randy, 2b minus 12b. Positive or negative? Why? Is it positive or negative? You said negative, which is correct. Why? because there's more negatives. That's two questions. Positives, negatives, which do I have more of? There's more negatives. How many more? 10b. Negative 5c, negative 4c. Anybody? What type of problem? Negative 9c. Good job, Tommy. Det. Perfect. Why can't I combine negative 10b and negative 9c? Because b and c aren't the same. Good. Could I multiply them? Yes. If I was asked to multiply those two things, I could. It would be 90bc. Good. Next problem. Positive. Because negative. Adding them, negative. Multiplying them, positive. We'll get it straight. 5 times b plus c. Minus 4 times 3b minus 2c plus 1. Maybe? Yeah. Very similar, right? Okay, Josh. First set of parentheses. Get rid of them. Why can I not just drop parentheses there? There is something in front of parentheses. The only time you can drop them is when what? There's no sign there, or there's a plus sign. Plus signs or no signs, dump them. That's fine. Numbers or negatives in front of it, you got to do something there. Now the second set of parentheses. Anybody, what am I distributing? Not 4, negative 4. Because we've done something with this, cross it out. Negative 4 times the second set. Somebody, or go ahead, anybody, read it out. What's it going to be? Negative 12b plus 8c minus 4. Perfect. You're good. Understand? Like terms. Lissa, give me 2 like terms. Perfect. Positive or negative? Why? Good. Because there's more negatives. And how many more? 7. Negative 7b. Well, anybody. What's 5c combined with? AC. How many c's is that? 13c. What is negative 4 combined with? Nothing. Negative 4 times positive 1. Last thing that we're going to do, and if you understood that, this is just as easy. Actually, we had some look beyond problems the other day that were this. And if you already know how to do those look beyonds, you're good. 8x minus 4 divided by 4. This is the distributive property. It's the same thing. On top, how many terms do you have being divided by? On top. How many terms? 2. 8's not a term, but 8x is a term. Okay? Terms are separated by plus and minus signs. So you've got an 8x on top, and you have a negative 4 on top. Each of those terms is being what? Divided by 4. So all you've got to do is take each term and divide it by 4. It's the same thing we did before, except for before you had like 4 times 8x minus 4, and you took each term and you multiplied it by 4. Now you're just taking each term and dividing it by 4. So you got 8x divided by 4. What is that? 2x. Negative 4 divided by 4. Negative divided by 4 friends, 4 pieces of candy. Each friend gets 1 piece of candy. Take this term, divide it by 4. Take this term, divide it by 4. There's your answer. It's the same thing as the distributive property, except you're dividing instead of multiplying. I'm going to go out on a limb. Some people might understand what I'm about to say. If you don't, that's perfectly fine. I'm going to explain to you why that works. Division by 4. Okay? If you take and divide something by 4, like a cake or a pie, if you divide something by 4, okay, and you eat that piece, you divide it by 4, you ate a piece. That's the same thing as taking what fractional part of it? 1/4 of it. Dividing something by 4 is the same thing as 1/4 of that something. Correct? So is 8x minus 4 divided by 4 the same thing as 1/4 of 8x minus 4? Sure. Huh? The second way? Like, yeah, I would too. I'm just showing you why it works. Because this is the same thing we were just doing, but division by 4 is the same thing as multiplying by a fourth. It's taking a fourth of it. So, do you see now this is the same property that we've been doing? 1/4 times 8x. Because what's a fourth of 8? 2x, right? What's a fourth of 4? Well, it's the same thing. Same thing. Next problem, nearly finished, guys. 6x squared minus 9 divided by 3. 6x squared minus 9 divided by 3. How many terms do you have on top? 6x squared, good, and negative 9. You're going to simply divide them both by 3, which is taking a third of them. 6x squared divided by 3 is how many x squareds? It's 2x squared. A negative 9 divided by 3 is a negative. That's your answer. Pretty easy. Yes, sir. Yeah, go ahead. 2 more problems. 12x minus 18 divided by negative 6. 12x minus 18 divided by negative 6. How many terms do we have on top? 2. 12x, negative 18. We're going to divide each of those terms by negative 6. Positive divided by negative, negative. 12x divided by 6, 2x. Negative divided by negative, positive. 18 divided by 6. Any questions? Maybe if I just change colors just constantly, it'd keep people awake a little bit better. 10x squared minus, subconsciously. 10x squared minus 15x plus 20 divided by negative 5. How many terms do you have on top? 3. 1, 2, 3. Each of those 3 terms, it feels like Christmas in here. It's Christmas. Each of those 3 terms are being divided by what? Negative 5. A positive divided by negative is a negative. 10x squared divided by 5 is 2x squared. Negative 15 divided by negative 5. Negative divided by negative, positive. 15x divided by 5 is, and the very last one, positive divided by negative, is a negative. That's where I'm getting my pluses and minuses. 20 divided by 5 is 4. More colorful anyway. Any questions?